In the next 20 minutes or so, I will talk about the Leiden ranking methodology and the quality and the robustness of our indicators. So I will try to explain briefly why we make certain choices in our methodology, the rationale behind it. As mentioned before, the Kisti-Cwts Leiden Ranking Traditional Edition is based on an enhanced version of the Web of Science core collection, and it provides analyses along 4 dimensions: impact, collaboration, open access, and gender. What do we mean with enhanced version of Web of Science? It's important to keep in mind when you look at our data that we work with the Science Citation Index, the Social Science Citation Index, and the Arts and Humanities Citation Index for our Leiden ranking system. So not included are the Conference Proceedings Citation Index, the Emerging Sources Citation Index, and the Book Citation Index. Moreover, we also filter down to articles and reviews. The reason to do so is that we want to base our analyses on a homogeneous set of scholarly outputs as much as possible. Mixing different scholarly output types too much creates, we think, an imbalance in the analyses. Further enhancements we make is that we have our own dedicated address team that studies and unifies the name and address variants of the universities in the Web of Science core collection. So we do not rely on the enhanced organization feature included in the Web of Science core collection. So for example, they study Leiden University or the University of Leiden and merge that into a single entity. Similarly, we have a campus, of course, in Leiden, also in The Hague. We ensure that those are merged together in a single count. In addition, we have a systematic allocation for affiliated institutions, and we differentiate between 3 types. An institution can be a component. So Kisti-Cwts itself, for example, is a component of Leiden University. It falls under the management and the financial system of Leiden University. So if a publication only lists Kisti-Cwts as an address affiliation without mentioning Leiden University, still this publication is counted or attributed to Leiden University. Next, we have joint research facilities or organizations. A striking example there is, it's a Dutch example, the Faculty of Dentistry in Amsterdam. This is a shared department between the University of Amsterdam and the Free University of Amsterdam. So if we identify ACTA, as the department is called, on the publication, it's allocated to both universities in that case. And finally, we have associated organizations. Associated organizations are organizations that show strong links to a certain university, but do fall under their own management and financial system. So they're really separate entities. The many teaching hospitals you have in the United States are a very good example there. The final enhancements we make is that we link the Web of Science core collection to all sorts of additional databases. So the PATStat or the PATStat database from the European Patent Office is a good example where we link citations from patents to scholarly publications. But more relevant for the Leiden ranking are the unpayable data, where we determine the open access publications, and the gender API and the other gender indicators that we calculate for the Leiden ranking. And finally, we create our own classification system of science for the Web of Science. But I will touch upon that in a few slides from here. So when we have the Web of Science core collection, Kisti-Cwts actually even filters it further down to a core publication set. We filter out local language literature, but also trade journals, business magazines, and popular science magazines. Or also journals written in English, but with a very strong national character, which show very few citation relations with the international English language literature. And this feels really counterintuitive, and we often get questions, or I should say even complaints from it from some countries. They say, well, it's unfair. Why do you exclude the local language papers? Because it reduces our publication output. But since we work in the Leiden ranking with field normalized citation impact indicators, it is actually proper to filter out local language literature, because what you do when including local language literature, you give an advantage to those universities that typically only publish in English language literature, being the US or the UK, but also the Netherlands. Because what happens is you add a large volume of, for example, German language literature to this larger corpus of publications, and the German language literature will give citations to this big corpus of English language literature, but will not receive citations in the other direction. English people will not read or hardly read German language papers. So there's a disbalance in the citation relations. And we studied it very carefully, and you see this depicted in these two graphs. So on the left-hand side, you see US universities, and we calculated the mean normalized citation score. So this is typically important for the mean normalized citation score and the percentage of highly cited publications we introduce in the Leiden ranking system. You see that if we calculate the mean normalized citation score based on all journals, plotted on the x-axis, and compare that to the mean normalized citation score when we focus on English language literature only, you see that structurally all US universities have a higher citation impact when we actually include local language literature. On the right-hand side, you see a graph, but then for French and German universities. And you see that if we focus on the English language literature only, that the mean normalized citation score is actually higher for those universities because they don't get the negative effect of the local language publications. So again, to make the comparison as fair as possible, we zoom in on English language literature only. And it's important to note that core or non-core in relation to journal does not say anything about the quality of the journal. It just relates to being international in terms of scope and reach or not. Fractional counting is employed by default in the Kisti-Cwts Leiden ranking, again when we look at field normalized citation impact indicators. And I think this was already very well explained by Jin-So Park in the previous presentation, but just to repeat it again, the way we work in the Leiden ranking is that if a publication has 5 authors and 2 of those authors belong to the same university, it counts as 2/5 or 40% for that particular university. And again, the reason to do so is to make the playing field or the comparative perspective as fair as possible and to prevent a full counting bonus when we are calculating the percentage of highly cited publications. The full counting bonus comes into play because when you count the mean normalized citation score or the PP top 10% using full counting, you're actually double counting more or less the publications in the whole calculation system. And this creates a bias. So typically when you use full counting, universities with large biomedical research departments, so typically an academic university hospital, get a benefit of this full counting bonus. So to get rid of this distortion, again, by default, the setting is fractional counting, but you can switch between fractional and full counting in the Leiden ranking system if you wish, but you have to be aware of this. There's not enough time to go into more detail, but the publication by Waldman and Van Eck clearly explains all the details around full and fractional counting. This slide, I think, is always very revealing to show. It shows 2 important aspects when counting citations and calculating normalized citation impact indicators. You see 7 research fields depicted here, and on the x-axis, the publication age in years is listed, and on the y-axis, the average number of citations per publication. And of course, the first effect you see is very straightforward. The older the publication is, on average, it will have had received more citations. It simply has had more time to attract citations. But also you see the striking difference between various research fields. So you see that, for example, after 5 years, a publication in biochemistry and molecular biology will have had about 15 to 20 times more citations attracted on average as compared to a publication published in the field of mathematics. So it's very important that we correct for the age of a publication, but also for the scientific field. And for the scientific fields, we use a very sophisticated system. It's called our publication-based classification system of science, which holds about 4,000 to 4,500 fields and subfields. In this system, we move away from the traditional journal-based classification systems of science, which are introduced, for example, in the Web of Science, where you have the Web of Science journal subject categories, or in Scopus, they're called the All Sciences Journal Classification System. There, they allocate a complete journal to a specific research field, or even to multiple research fields. And this already highlights a problem when you use those field definitions for calculating field normalized citation impact indicators. When you allocate a journal to multiple fields, the publications are also allocated to multiple fields, so you get very fuzzy distortions in your field definitions. In addition, there was always a problem with the multidisciplinary journals like Nature, Science, PLOS ONE, for example. These were grouped in these journal-based classification systems in a field called multidisciplinary sciences or multidisciplinary journals, which is of course artificial because the journals in terms of content are multidisciplinary, but the research itself that's being described in those journals, not. So what we do with our publication-based classification system is that we run an algorithm and publications are grouped together based on true citation relations. So the idea is that if publications show strong citation relations, they are grouped together in a research field or subfield. And that is what you see depicted here. Here you see a map of the 4,000 to 4,500 fields and subfields we have clustered with our algorithm, and it provides a much better and finer granularity to perform these field normalization processes when calculating those normalized citation impact indicators. So each circle represents a field or a subfield, and they vary in size. Obviously, research fields differ in number of publications. So big circle means many publications, small circle, smaller field. Also, proximity plays a role in this mapping of this research field system. Fields mapped closer to one another are more strongly related to one another. So we also look at the citation relations between the various fields. So this is the structure, and you will recognize the 5 major research fields we also use in the Leiden ranking system. So mathematics and computer science, physical sciences and engineering, life and earth sciences, biomedical and health sciences, and social sciences and humanities. Another important thing I would like to mention is the false sense of accuracy. And this is actually what Kisti-Cwts also does a little bit by itself. We present, for example, the PP top 10% values with 1 decimal value. And it feels like it's a very accurate measurement, but we should keep in mind that these are indicators and not physical properties like the length of your body or the weight of your body. These are indicators that are being calculated. Also, we see that management of universities are typically very much focused on the position in the ranking system. And again, I would like to highlight that, for example, the difference between position 100 and position 300, when you look at the PP top 10% for all sciences, just counted fractionally, is a mere 1.9%, way within the stability intervals that are also presented in the Leiden ranking. So you should not be bothered by increasing or improving your position with 40 or 50 points or places in the ranking system or dropping. You should just look at the value of your own university and see how it develops over time, because you can easily increase or decrease your position in the ranking because the differences are really small. So now on to the Leiden ranking open edition. Here, for the first time, we have now included the non-core publications as well in our ranking system. And I have to note that for the open edition, the gender indicators are excluded at this moment in time. This is because at the level of individual authors, the data still requires further studying and improvements. So here you see a summary of the process for creating the Leiden ranking. So it's not just us simply taking the data and calculating it. No, it consists of 4 core components. Again, we establish a core publication set for OpenAlex, a set of publications we deem reliable to provide robust indicator calculations. So we filter out a lot of stuff. Also for this database, we create our own publication-based classification system. And together with our CWTS organization registry, we carefully study the publication university links. And those 4 components ensure that we can calculate the indicators. So first, on the publication university links. At the start, we already addressed quite some issues with the OpenAlex team. We saw, for example, incomplete coverage of raw affiliation strings, incomplete institution identification, but also raw affiliation strings often just refer to one single institution. So we have this example here that originally this particular publication was only linked in the original OpenAlex database to LATMOS, the very first institute, while there are 3 other institutes affiliated to this publication, each with their own research organization registry identifier. So when we published our first Leiden ranking in January 2024, we started studying the data and the address affiliations with the database snapshot produced in February 2023. And we took the data actually from the Leiden ranking traditional edition based on Web of Science, and we knew, of course, for which publications they had to be linked to that university because we had the data from the traditional edition. And then we checked if those publications were also attributed to that particular university in the OpenAlex database system. And we saw that there were many, many false negatives. So in the end, the first Leiden ranking open edition was based on the database snapshot of November 2023. And you see, as compared to the previous slide, the number of false negatives was greatly improved, but still there remains an issue to improve the data. Now I would like to go to the aspect of core publications. So here for the OpenAlex database system, we have to follow an adjusted methodology because the classification system of document types or works and also sources is different in the OpenAlex database system. So we exclude publications that do not have an article word type or journal source type, or an article book chapter work type and a book series source type. Again, we exclude publications that are not in English. We exclude publications that have too much metadata missing, and we exclude again the sources that do not have a very international focus and the trade journals, business journals, and popular science journals. So what does it look like when we get to the core publication set? Here you see all the works indexed in OpenAlex with publication year of 2000 and onwards. So we start with about 170 million publications, but then if we go stepwise through filtering the data, I should say, after step 7, we are left with about 40 million publications belonging to the core set, which is suitable, we feel, for bibliometric performance analysis in a ranking system. So we have addressed quite some issues also with the OpenAlex team by studying these data with the ambition to get these data improved. So we see works without a work type, incorrectly classified sources, works with missing primary source assignment, journal articles incorrectly assigned to repositories, but also other improvements are possible. So the availability of the language, availability of the countries, so country affiliations missing, but also the work types need to be modified. And last but not least, also improved identification of institutions. Still, we notice that there is room for improvement in the address affiliations in the data of OpenAlex. So we did a careful study of how core publications between the two databases compare. So we took a set of publications for the period 2019 and 2022, which were both indexed in OpenAlex and in Web of Science. And you see that the overlap is actually quite good. 92% of the publications are listed being core publications in both database systems. But at the same time, you see in the top right corner, close to close to 300,000 publications which are considered core publications in OpenAlex, while they are considered non-core publications in the Web of Science. This is mainly due to the fact that the document type and source type classification in OpenAlex is less fine-grained and less accurate. So these can be considered false positives. Similarly, we also see almost 400,000 publications being assigned core publications in the Web of Science, but considered non-core publications in OpenAlex. This has to do with quite often missing metadata of those publications. We took a random sample set, studied it, and again, it seems that these are false negatives because of missing metadata of the publications. So as I said, more is not always better. So what to do with including the non-core publications? How should we include them in the Leiden Ranking Open Edition? We still feel that non-core or core publications should not be included in field normalized citation impact indicators because of the problem I explained earlier on. Non-core publications receive substantially less citations than the core publications. Universities with many non-core publications will be disadvantaged in that case. And this typically applies to universities or countries with a large non-English language area. So for example, Brazil or Russia. So how does it play out for Korea? Here you see a scatter plot. On the x-axis, the Leiden Ranking Traditional Edition, and on the y-axis, the Open Edition. And here we are looking at P, the publication output. And you see that systematically, almost all Korean universities have a slightly higher publication output in the Open Edition, which does not come as a surprise because OpenAlex simply collects and indexes more scholarly outputs. For the percentage of highly cited publications, you see that all Korean universities structurally have a higher PP top 10%. So how do we need to include then the non-core publications? You see that there's a general switch on the Leiden Ranking website where you can switch between core publications, which is set by default, and filter it out. So we have introduced new indicators when you are looking at the ranking with the non-core publications, and these are listed over here. So we have introduced similar percentages, but this is a PP, a percentage of publications with at least 10 citations, at least 20 citations, and onwards. So mind you, these are not field normalized citation impact indicators. To round things up, there are many opportunities and still challenges with the non-core publications. The non-core, they capture diverse research outputs. Typically, the social sciences, art, and humanities are better reflected in terms of publication output. But there's also the technical challenges. They often lack metadata. And there's also regional biases in terms of coverage. And for us, the conceptual challenge remains how to include non-core publications in an international ranking system where you provide an international comparative perspective that it is still being used in a responsible way by our users across the globe. Thank you.